finish the explanation of the chapter of the forces and equilibrium. Okay, as an application for this chapter, I've put three examples from the official exams mainly. In this question, the law of mass for 500 grams. Whenever we see the given mass, 500 grams, we convert it into kilograms. Is suspended by a spring of stiffness K equals 40. The initial length is also called the free length of the spring, so that it's the length of the spring in the absence of any load or mass connected to it. It's when no object is suspended is known to be 50 centimeters. We write L0 equals to 50 centimeters. Redraw the figure and draw the forces. Of course, the weight is from the center and the tension is from the point of contact between the spring and the ball. Name and calculate downward force. What is the downward force? The weight. Calculate it. Weight equal mass times gravity. We don't forget to convert the mass into kilograms. Okay, divide by 1000, which is the conversion into kilograms, equals 5 newtons. Give the four characteristics. Give means without justification. The point of application, it's the center of mass, or we say the center of gravity of the ball. Since the weight is a force acting from distance, so its point of application is always the center of mass. Line of action vertical, direction downwards, and magnitude we calculated, which is 5 newtons. Write the relation of between the two forces at equilibrium. This question is always familiar. We should be familiar with it. So the condition of equilibrium is tension and weight equals to 0. Notice the vectors above each of these three terms. Tension vector plus weight vector equals 0 vector. Then we send the weight vector to the right. Tension vector equal minus weight vector. We remove the vectors and the minus. Tension equal weight. This is the magnitude relation. Okay, find the elongation. Now we can deduce from this relation tension equal weight. The tension equals to 5 newtons. From the tension, we can calculate the elongation using Hooke's law. As I said earlier, that whenever we use any law, we should write Hooke's law. We should write the name of the law and the law itself before using it. Okay, deduce the final length. You use the equation of the elongation L minus L0, and we find L. Okay, mathematics. In example 2, a box of mass of 520 grams rests on a table. Since we have no spring or string, so of course there is no tension force. There is normal force. This example is similar to that, despite that the force here is normal and not tension. This and classify. Classify means whether the force is contact or force acting from distance. As you can see, the example is similar. In this example, we have another force, which is the magnetic force. Here in the third question, an iron block is put under the magnet, so there is a magnetic force. We can see here in the condition of equilibrium, there are three forces: weight, tension, and magnetic force. I call it Fm, the magnetic force. How can we write the condition of equilibrium in the magnitude relation? We just send one vector to the right, or two, whatever. What vector, which one should we send? We should take the forces that have the same direction together on each side. We can see here that the weight is downwards and the magnetic force is downwards if we draw the block. So, and weight and magnetic, while the tension is upwards. So weight and magnetic have the same direction, while the tension is upwards, opposite to it. In the last video, I explained the principle of interaction. Thank you.